Hey there, Mr. Monahan here for Expo 9.4a, factoring to solve quadratic equations. We are going to look at our objective today. You can write at the top of the page. What we're going to look to do today is to solve quadratic equations again, and we're going to do that by factoring. Factoring was our huge topic from Chapter 8 that we looked at, so we're going to have to remember some things about how to factor those polynomials today. And we're going to use that as a way to solve our quadratics, looking for those zeros. First, some review. We're going to consider the equation y equals negative 1/4 x minus 2. First question is if it opens up or down. This one will open down because the number out front is negative. Okay? The number out front does two things. It determines if it opens up or down, and it determines if the graph will be wider, narrower, or the same width as x squared. This one will be wider because the blue 1/4 that I traced is a fraction. When it was a number between 0 and 1, what we said was that made the graph get wider. Big numbers made the graph get narrower. And the effect that the negative 2 has on the graph, the negative 2 at the end, is going to move the whole graph down 2 units. The whole graph will move down 2 units. Okay? Just a little bit of review of what's happening with some of those pieces there. All right, something called the zero product property here. Here we have if x plus 2 times 2x minus 5 is equal to 0, what must be true? That's kind of the question right here. What must be true? Well, if I know that a times b is equal to 0, there's only one way. Okay, well, there's something that must be true if I have a product of 0. The only way that this equation is going to be true is if a is 0 or if b is 0. Or it could be both. They could both be 0. But one of them definitely has to be 0. Because if I'm multiplying a times b and getting 0, that tells me that either a is 0 or b is 0. Otherwise, if they're both not 0, they're not going to multiply to 0. It's impossible. So back to the original question. If x plus 2 times 2x minus 5 is equal to 0, either x plus 2 equals 0 or 2x minus 5 equals 0. One of these two things must be true, or both. This is called the zero product property, and it allows us to solve for x. This right here, this thing right here, this is called factored form. So if we can get a polynomial into factored form, then we can use the zero product property to figure out what x's give me 0 out. So we could solve this one. What this means, if I'm looking for what x's give me 0, if I solved x plus 2 equals 0 for x, that would mean subtracting both sides by 2, and what I would end up with is x equals negative 2. What that tells me is if I put negative 2 right here, I would get a 0 in the first parentheses, and 0 times whatever the second parentheses is will be 0. Or I could solve this one for 0, add 5 to both sides. 2x will equal 5, so x is 5 halves, or 2.5, whatever you want to write it. But what that tells me is if I put 5 halves in right there, then that would give me 5 minus 5 in that parentheses. So that second parentheses would be 0. So whatever the first one is times 0 will give me 0. This is called the zero product property, and that's what we're going to use to solve these. All right, so using the zero product property, you see 6 problems here. Everything is already in factored form, which means we're ready to just try to split those up and solve those. So if this is true, 4t plus 1 times t minus 2 is 0. Either 4t plus 1 must be 0, okay, or t minus 2 must be 0. Those are my two possibilities. So I'm going to solve the first one by subtracting 1 from both sides, and then I end up with 4t equal to negative 1. Divide both sides by 4, so you end up with t equals negative 1/4. That's one of our solutions for this polynomial, okay? The other one simplifies much faster, or solves much faster. Just add 2 to both sides. T is equal to positive 2, and that's it. So you could have like a check step here. If I put negative 1/4 in right here, okay, what I would get is 4 times negative 1/4. If you do that, you end up with negative 1, okay? That gives me negative 1 plus 1. These two right here now make 0. So 0 times whatever the second parenthesis is would be 0. Okay, or I could put a 2 in right here. Okay, if I put 2 minus 2 in there, that gives me 0. So whatever the first one is, when I plug in 2, times 0 would be 0. So these both give me zeros of the parabola. If this was graphed, it would be a parabola. Okay? All right, so this one, there's two factors that are multiplying to 0. So that tells me I should split them up to solve. One possibility is that 4x equals 0. The other possibility is that 5x plus 1 equals 0. Okay? The one on the left, if I want to solve for x, I'm going to divide both sides by 4. X equals 0 is one of my answers. Okay? The other one here, I would subtract both sides by 1 first. I would have 5x equals negative 1, or x, when I divide by 5, equals negative 1/5. Okay? Let me go through checking those, because that's going to be something that is good for you to see. If I plug 0 in to this equation now, I would get 4 times 0 times 5 times 0 plus 1. Okay? Plugging in zeros for x's. So I get 0 times 5 times 0 inside goes to 0, plus 1 is 1. So 0 times 1, which equals 0, which is exactly what it was supposed to equal. So putting in 0 gets me out a 0. Over here, 4 times negative 1/5 times 5 times negative 1/5 plus 1. Okay. Outside, I get basically negative 4/5. Inside, I get negative 1 plus 1, which is 0. So negative 4/5 times 0 equals 0. So we're finding the two things, maybe it's more than two things, which we'll see in just a second, that if we plug that number in for x, it makes one of the parentheses go to 0, which makes the whole product go to 0. So x plus 1 times x minus 5 equals 0. That means either the first factor equals 0 or the second factor equals 0. So subtracting 1 from both sides on this one, I get x equals negative 1. Adding 5 to both sides on this one gives me x equals 5. Okay, plugging in to check. If I plug negative 1 in, I would get negative 1 plus 1, which is 0, times negative 1 minus 5, which is negative 6. 0 times negative 6 equals 0, so I checked that one. If I plug 5 in, I get 5 plus 1, which is 6, times 5 minus 5, which is 0, equals 0, so that one is checked. Those are the two x's I could plug in that would give me a 0 out. I'm going to have you pause the video and do the next two, and then the third one will be a challenge one. So after you pause the video and try those two, click play. Those two answers will pop up, and then the third one will go over together as kind of a challenge. Go ahead and pause the video right now. So there's answers to the first two. The first one, you should have had answers of -3/2 and 4. The second one, you should have had answers of 2/7 and 4/5. So that's what we should have been looking at here. The last one's kind of a challenge one, but really every single one of these products, 1, 2, 3, 4, 5, will give us another answer for x. So this one will really have like 5 answers. So each piece needs to get set equal to 0. X equals 0. Well, that's already an answer, so that one's done. 9x minus 8 equals 0 needs to get done. So let's just solve that while we're here. Add 8 to both sides. 9x equals 8. So x equals 8 over 9 when you divide both sides by 9. So that one's done. That one's done. We need x plus 3 equals 0. Subtract 3 from both sides. X is -3. That one's done. X minus 4 has to equal 0. Add 4 to both sides. X must be 4. So that one's done. And then the last one, 3x plus 7 equals 0. Subtract 7 from both sides and divide by 3. -7 over 3 would be that answer. So we could put as many parentheses in a row as we wanted. This one isn't a parabola if you graph it, but this would have 5 places where it crosses the x-axis. So these were all in factored form. The next step is we need to make sure we remember how to factor. So if we get something that's not in factored form, will we be able to get it into factored form and then use that zero product property we were talking about? So this means you can solve a quadratic if you can get one side equal to 0 and then factor the other side. So this is why Chapter 8, factoring was such a big deal. So remember how these are supposed to work. We have one side equal to 0, so here we're okay. If there was a number over here, like a 10 or something, we would just have to subtract it and get it over there. So we already have it set equal to 0, so that's good. So we try to factor this now. Okay, when we factor now, we're solving by factoring, which means we're going a little extra step compared to what we did in Chapter 8 with it. So remember how these factor. The only way to get x squared is x times x. Both signs here were positive. That means our signs had to be plus plus. We should have at least one example of every set of signs that are possible here. And then we look at the factors of 15, and we say, do either of those factors add to 8? This one does. So we have x plus 3 times x plus 5. And that's where we stopped in Chapter 8, but now we need to solve this by factoring. So x plus 3 could be 0, or x plus 5 could be 0. Those would both be solutions to this parabola, to this quadratic. If you subtract 3 from both sides, this one gives you an answer of -3. If you subtract 5 from both sides, this one gives you an answer of -5. Okay? So we factor first, then we solve by factoring. Let me just give myself a little bit more space on this one. Okay, that's better. So this one, we have one side equal to 0, so we're set there. So we're going to factor this now. Okay, now I see that I have a -c term, which means I need one plus and one minus sign for my signs. Okay. Now I'm looking at the factors of 14 and seeing if any of them are 5 apart from each other. Okay, when the third term is negative, it turns into that subtraction. So 2 times 7 gives me 14, and 2 plus -7 will give me -5. Remember, this was negative in the middle, which meant I want the bigger number of my two factors I choose to be by the minus sign. So this will give me two potential answers, m plus 2 equals 0 or m minus 7 equals 0. On the left, we're subtracting 2 from both sides, so -2 would give me a 0 there. On the right, we're adding 7 to both sides, so m equals +7 would be my other answer. Okay. All right. p squared plus p minus 20. Again, we're already set equal to 0, so we're ready to factor, keep it equal to 0. P times p, the only way to get p squared. I need a plus and a minus because this is a negative 20. And then my factors of 20, 1 times 20, 2 times 10, or 4 times 5. 4 times 5 are the ones that I want because they're 1 apart, and I want a positive 1p to be my middle term. Since this middle number is positive, I want the bigger number to be by the plus, the smaller number to be by the minus. Okay? So either p plus 5 equals 0 or p minus 4 equals 0. Those are my two possibilities. So p being negative 5 is a possibility. P being positive 4 is a possibility. Okay? Just to show you it once, let's go through it and plug those numbers into our original equation, p squared plus p minus 20. Okay? See if plugging those in gives us 0 like we thought they would or like we hoped they would. So p squared plus p minus 20. Let's try it with negative 5. So that would be negative 5 squared plus negative 5 minus 20. Okay? Negative 25 squared, or sorry, negative 5 squared is positive 25, and then 25 minus 5 minus 20, well, that equals 25 minus 25, which equals 0. So negative, if you plug in negative 5, you get out 0. Let's try it with 4, okay? So 4 squared plus 4 minus 20. Well, 4 squared is 16. 16 plus 4 minus 20. 16 plus 4 is 20, so I have 20 minus 20 equals 0. So what we're finding are the values of p or x or whatever letter it might end up being that when I plug that value in, I get 0 out. We're finding the x-intercepts of the graph is what we're finding. Okay? One more time, let me give myself some more room, and then we'll be ready to go. Okay, so this one's a little bit tougher to factor, and the reason is there's a 2a out front. This makes everything a little bit tougher to factor. When that happens, see if there's a greatest common factor. This time there is not. We have to just try to factor this the way that it is. So what I know is that since 2 is prime, I need one of my parentheses to have a 2a and the other one to have an a. I have a positive 18 but a negative 15. What that meant for my signs was that I had to have two minus signs, minus, minus. Okay? Now, I have to look at the factors of 18. I have 1 times 18, I have 2 times 9, or I have 3 times 6. I'm trying to find something that makes 15, but remember, whatever I put in this spot here is going to get doubled. It's going to get multiplied by 2. So you have to just keep that in mind. For whatever goes there will have to get multiplied by 2. Okay? All right, so then let's look. If you look at 3 and 6, there's a way to get 15 with 3 and 6. If I put the 6 here, what those two would give me, well, now put the 3 here, what that combination would give me, these two would give me negative 3a, these two would give me negative 12a, and those add to negative 15a. So that's what I wanted to happen in the middle. Okay, these were the hardest ones to factor, the ones with numbers out front in front of the a squared. But this is the right way to factor this. So now I'm solving either 2a minus 3 equals 0 or a minus 6 equals 0. Okay, on the left, we add 3 to both sides, and we divide by 2. You can leave it as a fraction if you want, or you could write that as 1.5. On the right, all we need to do is add 6 to both sides, so a is 6. And again, we could go plug those in, and it would prove it to you that those are the answers. So what we talked about was factoring and solving by factoring. So solving by factoring is when we have the equation set equal to 0, and we use that to try to solve for those x-intercepts without having to graph it. Okay. Remember, to solve by factoring, you must get one side equal to 0 before factoring. One side has to equal 0 before you factor. So if you run into that situation, all you have to do is basically subtract the 18 back over. So we have 4x squared minus 21x, now minus 18 equals 0. Okay, then I would go and try to factor this. Okay, same thing over here. I'd have to add 49 to both sides. So I'd have x squared plus 14x plus 49 equal to 0. Okay. All right. So then I would go and try to factor this. Let's do one of them. Well, maybe we'll have time for both. Looks like our video is still not too long yet. On the left is a little tricky to factor because over here for 4, we have 1 times 4 or 2 times 2 is a possibility. For 18, I have 1 times 18, 2 times 9, or 3 times 6. Okay. With this one, we do need a plus and a minus sign because this is a negative 18. I'm going to do this one with 4x and 1x. Okay, and the way we want to do this is with the 3 and the 6. So the 1 and the 4, the 3 and the 6. You can do 4 times 6, which is going to give you negative 24. And then the 1 times 3. So what we have here is positive 3x and negative 24x. Those give me negative 21x in the middle. Okay, so we have it factored now. That one's pretty tough to factor. Then we have to solve by factoring. So either 4x plus 3 equals 0 or x minus 6 equals 0. Over here it solves pretty quickly. X equals 6 is an answer. Just add 6 to both sides. Okay, over here we subtract by 3 first. So 4x equals negative 3. Then we divide by 4, so x equals negative 3/4. So those are the two values of x that would be x-intercepts on the graph. Over here, it's a plus-plus problem, so that's not so bad. The factors of 49 that add to 14, would be 7 times 7. So x plus 7 is equal to 0. So this is kind of interesting. X plus 7 equals 0. Or x plus 7 equals 0. Those are exactly the same thing. Oops, I messed that up though. So I need to subtract 7 from both sides. So x equals negative 7, and x equals negative 7 again over here. So this is one of those ones that just has one solution. So looking at the graph of it, it would just be resting right there on the x-axis. Last thing, okay, this one, 4x squared minus 16, could be solved using today's method or with 9-3's method. If I was looking at this one, 4x squared minus 16, we could solve by square roots, okay? Because what we could do, 4x squared minus 16 equals 0. What we would do is add 16 to both sides. So we would have 4x squared equals 16. We would divide both sides by 4. X squared equals 4. We would take the square root. When we do that, remember that we have to include plus or minus. And yesterday we would have said the answer to that is plus or minus 2. Okay? Or we could factor this, and this is a really good one to remember how to factor. Okay? 4x squared minus 16 equals 0. How do we factor that? This is called a difference of squares. So what happens is we take the square root of the first term, and that's 2x. We do a plus or minus, a plus and a minus. We do the square root of the second term. 2x plus 4, 2x minus 4. So when you solve these, 2x plus 4 equals 0, or 2x minus 4 equals 0, On this one, you subtract 4 from both sides, get 2x equals negative 4. And negative 4 divided by 2 is negative 2. Over here, you add 4 to both sides and get 2x equals positive 4. And divide by 2, x is positive 2. This answer in red is the same as this answer in green. It's just the plus or minus 2 is saying exactly that. X equals 2 is an answer, and x equals negative 2 is an answer. Okay? Why can't the other examples from today be done both ways? The examples from today are trinomials. Trinomials can't be solved by square roots. As simple as that. Trinomials can't be solved by square roots. Okay, so even taking this one up here, okay, you would not be able to solve this one by square roots, because what you need to do is you need to get x squared all by itself. So I would have to subtract like the 14x over. But taking the square root of something with an x in it doesn't give me an answer that's possible. So you can't do the square root method for trinomials. And I think that's the last thing for today. Yes, it is. So that's it for today. Thanks for watching. Go ahead and get